Okay, let's make a table of values for a function of two variables. So what we have here is a function. It's the simplest function I can think of that's not linear, which makes it at least a little teeny bit interesting. Now, how are we going to make the table? We know that in regular old algebra, what we would do is we'd make x and then y. But the actual variable that we're getting for answers here is z. We could add an extra column, and I have seen this in some books. They're never math books, but it gets very, very difficult to organize the information, and we can't see any patterns what's going on. So we're not going to make a table like that. What we're going to do instead is make a table of values pretending we're looking down at the plane, the xy plane from above. So what I'm going to do is, let's put a little box around this. Stay away from that. I'll put a little x right here, I'll leave a little space, and I'll put a big horizontal line like that. I'll put a y over here like this, and then a big vertical line like this. And what I want to do is just pick some evenly spaced x values. That's what we did in plain old algebra. So what I'm going to do is just make myself some columns. Now when I say evenly spaced x values, I don't mean the cells are the same. I mean the delta x's are the same. So for example, I could start over here, say at -3. I can pick any value I want to start with, and what I want to do is make sure I'm adding the same amount of x each time. So for example, if I add 2 and I go up to -1, in order to make a table of values that's consistent with what everybody else does, I'm just going to keep adding 2 each time. So I'm going to get 1, and then 3, and then 5, and I guess we could go as far as 7 if we wanted to. Now, I want to do the same kind of thing for y, so I'm going to draw a bunch of horizontal lines like this. Okay, and I can see all those from above, which is good. Now what I want to do is start down here and then add my y's as I go up. Now I'm just going to start at -4. It's a little bit different than starting at -3. And instead of adding 2 each time, I can add a different delta y than I use for delta x. I'm just going to add 3 each time. So I'm going to go up to -1 and then add 3 each time. Now I'm stuck. So how about 2, 5, and 8? Now I want to start filling the cells. Let's pick the easiest one I can. I'm thinking this one right here. Now how do I do that? Well, what I want to do, I see that's the column where x is 1, and that's the row where y is -1, and then I want to plug back into my function. So 1 squared plus -1 squared, that's 2. Yay, we have our first number. Now when it's not linear, we actually just have to keep doing this. I'm going to take my time and just do this. 3 squared plus -1 squared is 10. 5 squared plus -1 squared is 26. 7 squared plus -1 squared is 50. I'm going to start working back the other way. -1 squared plus -1 squared is still 2. -3 squared plus -1 squared is 10. And you can see there's some symmetry involved, but we're just going to start filling in everything else. You can take your time and do this too. So this is just going to be 13, and this is going to be 5, and this is going to be 5 again, and this is going to be 13 again, and this is going to be 29, I think. And this is going to be 53. Let's go down to the bottom row. This is going to be 25. -1 squared plus -4 squared is 17. I can still see those good. I get 17 again. There's our symmetry. I'm going to get 25 again. 5 squared plus 4 squared is 41. 7 squared plus 4 squared, I think that's 65. Okay, just still filling in the table. By the way, even something like decimals can't do this. You can get a spreadsheet to do this. We won't really be doing this often enough. We will be looking at tables of data, but usually they're generated by something else. Small tables of data, however, we can do this. So here we go, still working. 34 and 26 and 26. There's our symmetry again. I have 34 and 50 and 49, I think that's 74. Here we go. 64 plus 9 is 73. 64 plus 1 is 65. 64 plus 1 is 65. 64 plus 9 is 73. And there's our symmetry again that we see. Let's see here. 64 plus 25 is 89. Kind of embarrass myself here, I guess. 64 plus 49, I think, is 113. There we go. So this is how we make our table of data. We can instantly see where each of the numbers comes from. I know that 29 must have been 5 squared plus 2 squared, etc. Now, one of the things that we're going to be doing a lot this semester is looking at rows or columns one at a time and just see what's going on. I just want to make sure we introduce that here before we walk away. For example, if I want to look at just this row, nothing stopping me as I can. Let's put a little bar up here so I can write what's going on here. We are freezing y at 5, right? If I freeze y at 5, you can see that only x changes. So I'm going to write this down. I'm freezing y at 5. So what we're actually looking down here, right, is actually f of x. We said 5. The formula would turn into x squared plus 25, like that. Now, this is actually a parabola because it's a function of one variable, and you can see this is acting like a parabola. It's coming down, and then it's going back up. So I'm thinking whenever we hold y constant in this fashion, we are going to see a parabola for this function. I can do the same thing with x. I'm hoping I can get a slightly different color to do this. How about green, if the green works? I'm just going to pick a different column this time. I pick a different column this time. I'm going to get something like that. You can see here in green, I'm freezing x equals minus 1. The equation for that would be f of minus 1y. If I look at the equation, what that's going to be is going to be 1 plus y squared, which again is a parabola. And you can see this does behave like a parabola. It starts at 65, it comes down to 26, and then it starts going back up. So that's basically it for making a table, making sure that every time we do this, look along the rows and see if there's any kind of patterns that you can see, and look along the columns and see if there's any kind of pattern you can see. But that's it.